hope you're doing good today. So we're moving on into our Unit 6, and we're doing Lesson 6.2, which has to deal with some math with chords and arcs. So I know in the last lesson we learned specifically what chords and arcs are, but we're going to take it a step further and we're going to learn some theorems that we're going to help apply this information. Okay, so let's jump into it. All right, so the first thing we're going to look at on this first one, it says congruent central angles have congruent arcs. And what I mean by this is if I'm given two circles, and inside these circles, I have two different central angles. So I'm going to draw a central angle that way. I'm going to draw a central angle this way. And I'm going to call this C. And I'm going to call this B here. Actually, I'm going to call it, I'm going to call this A. I'm going to call this C. I'm going to call this B up here. And I'm going to call this D. I'm going to call this E. And I'm going to call this F. So in this situation, if both of these arcs are congruent, meaning, or both of these angles are congruent, angle BCA, if this is congruent, and angle DEF, if this is congruent, I just drew two marks and they're proving that those two are congruent, then by definition, the angles have congruent arcs. So in this situation, if the two central angles are congruent, then the two arcs are congruent. So that means from point A to point B and point D to point E, those are going to be congruent. So this is what it would look like. I would draw AB, the arc AB is going to be congruent to arc DF. Because since the central angles are congruent, then your two arcs would be congruent. Okay? All right, let's move on to the next one. So the next one says, if you have congruent central angles, then they have congruent chords. So it's kind of the same thing. If the two arcs, or if the two central angles are congruent, then the arcs are congruent. If the two central angles are congruent, then they have congruent chords. So for instance, if I'm given a circle that looks like this, so I'm going to draw a circle. And then in this situation, I have a center. I have one angle going this way, and then let's say I have another angle going this way like this, okay? And then I have chords that are connecting those two. You see how this looks, okay? So in this example, if the central angles are congruent, then what that tells me is my two chords are congruent. So I'm going to label this AB, and I'm going to label this DE right here. So since my central angles are congruent, then that means my two chords would be congruent as well. So the chords are line segments, so that means line AB would be congruent to line segment DE. Because since the central angles are congruent, then the two chords are congruent as well, okay? Now in my next theorem, it says congruent chords have congruent arcs. So for example, you might be given two circles. So let's go ahead and draw two different circles here. And then in these circles, I'm going to draw two different chords. So I'm going to draw a chord right here, and then I'm going to draw a chord up here, okay? And what it says, if you have congruent chords, meaning this chord right now would be congruent to this one, then that means their two arcs would be congruent as well. So that means if I label this AB, and I would label this DE, if the two chords are congruent, then that means my two arcs would also be congruent. So that means arc AB would be congruent to DE. Okay? And then lastly, chords equidistant from the center are congruent. So for example, if I have a circle, I have a center, and then I have two chords being drawn here. So let's say I have two chords going this way. From the center to that chord, from the center to that chord, if those two lines are congruent, chords equidistant from the center, so both of those are going to be equal in distance from the center, then those two chords would be congruent. So let's say I named this CD, and let's say I named this AB, then that means AB line would be congruent to line CD. So this is just a bunch of definition type stuff, but the thing you have to understand is if the central angles are congruent, then the chords are congruent. If the central angles are congruent, then the arcs are congruent. It's just all three of those things kind of tie together. Central angle, chords, and the arcs. If any of those are congruent to each other, then all three of those things are all congruent to each other. So they all tie into each other, okay? So we're going to take all this, we're going to apply it to our examples, and then hopefully be able to ask some questions and apply it to our skill checks. So let's jump over to those examples. All right, so in this example, it looks like we're given a circle, and it looks like I have two chords with some lines going to each one of these chords. So in this situation, we know that if two chords are equidistant from the center, then that means those chords are going to be congruent to each other. So with that being said, it looks like from my center to my chord here is going to be 4.9. So that means from here to here, if you look, there's one mark on both one of those. So that means both of these are going to be equal. So if this is 4.9, this would end up being 4.9. So again, by definition, if the chords are equidistant from the center, then that means the two chords are congruent. So that means if these two are congruent, that means these two sides up here are also going to be congruent. So if this is 6.3, this is 6.3, which means both of these are going to be 6.3 as well. So that means those added together. So if I did 6.3 plus 6.3, I get 3 and 3 would give me 6, and then would give me 12 would be 12.6. So that means this entire line right now would be 12.6. So since they're equidistant from the center, that means this entire line would be equal, or that chord would be equal. So x would in return equal 12.6 as well. Okay, because we're using that last definition that we looked into. Okay, so let's jump over to example number 2. Okay, so on example number 2, it looks like we are given a chord, and we have an arc here as well. And then it looks like we're given the radius of a circle. So right now, if you look, we're just looking at some of my terminology that I looked into a while ago. If you look, if I actually rotated this radius all the way over here, so I brought x and brought it over here. If you look, it's going to create a right triangle here. You see that? So I actually took this and I rotated it around, so this is actually going to end up being x. So right now, if you look, this whole chord right now is going to be 10. So half of that chord is going to give me 5 here. So I had just now created a right triangle that looks like this. So this is my right triangle. So this is going to be 4.2, this is going to be 5, and this is going to be x. So I learned in my triangle section, I can use Pythagorean theorem to find any missing side. So that means I'm going to do 4.2 squared plus 5 squared, and that's going to give me x squared here, okay? So if I did some math here, 4.2 squared plus 5 squared is going to give me 42.64. And now, oh, this should be x. Sorry, this should be x. Should be x here. Now to get x by itself, I have to take the square root of both sides. So I'm going to take the square root of 42.64. And so x is going to equal 6.53. So ladies and gentlemen, all I did was I rotated that diameter over, created that hypotenuse, and I used the right triangle to end up solving for that missing side there, okay? Okay, and lastly on example number 3 here, looks like I've given a circle. Looks like I have a line going from the center of the circle to the chord at 90 degrees. And then also I have my radii going here. But if you look, since it's 90 degrees with that chord, it's going to be cutting it in half. So that means right now, if I wanted to find this, so I'm going to actually call this y, I have to find this little section right now first by using Pythagorean theorem. Then to get the whole thing, I have to double what y is. So let's go ahead and find the missing side length here. So right now, this is my hypotenuse, and these are my 2 legs. So I'm going to do 8 squared plus y squared equals 15 squared. So 8 times 8 is 64. 15 times 15, I think, is 225. Yes, I'm correct. Then I'm going to subtract 64 on both sides. So you should get y squared equals, so minus 64, should give me 161. And then I'm going to take the square root of 161, which is actually going to give you 12.6886. So 12.6886, okay? So now what I'm going to do in order to find this, remember, to find that, I only found half the line. So now to find x, I have to double what y was, okay? So then I'm going to take what y was down here and I'm going to multiply that times 2, which is actually going to give you 25.38. So 25.38 would be that final length there, okay? So ladies and gentlemen, this is turning this and using that math that we just learned on those terminology and applying it to some examples. So take this, ask some questions if you need to, and then move over to your skill check and make it work.